Let's continue with the definition of the rational class. I've added additional functions to the class. We are overloading the augmented operators plus equal, minus equal, and the rest of the augmented operators. Also, we are overloading the subscript operator. So if the index of the subscript is 0, the numerator of the rational object is returned, and if the subscript is anything other than 0, the denominator of the rational object is returned. And then also we are overloading the increment and decrement, prefix and postfix increment and decrement operators here as well. Now let's look at the implementation of these functions. Here is the augmented operator plus. What happens here, the operation will look something like R1 plus equal R2. And that addition operations, this augmented addition operation, basically means that R1 is equal to R1 plus R2. So the parameter is added to the implicit object, in this case R1, and the sum is stored back in R1. So the function add is utilized here. So this add basically adds the parameter second rational, which in this case could be R2. It adds it to the implicit function and stores it in the this pointer, of course dereferenced, star this, which is refers to the object, implicit object R1 here, and that implicit object, in this case R1, is returned. Same with augmented operation here, subtraction and multiplication and division. The idea is the same in all of them. And then the subscript operator here, basically it allows us to use indexing. So if the parameter index is 0, then something like the rational object R1 index 0 will return the numerator. So if our rational object R1 is equal to, let's say, 3/4, then R0 returns 3. And R1 at any other subscript, any other index, say 1, will return the value of 4, the denominator. Now moving on to the increment and decrement operators. We have prefix increment and we have postfix increment. The operator for both of them is the same, operator plus plus. So the compiler needs to have a way to distinguish between these two operators. For that, the postfix operator plus plus receives an integer dummy variable. That's how the compiler distinguishes between the two functions, basically. So if a postfix increment is used, the function in line 150 is called, and if a prefix increment is called, the function in line 137 is called. Now, how does the increment work for fractions? For example, if you have a fraction a over b, rational object a over b, and you add 1 to it, it is like adding a over b to the rational object b over b, right? Because b over b is equal to 1. And then adding, since they have the same denominator, adding would be simple. It will be, the numerator will be a plus b, and then you'll divide it by the denominator b. So there's no change in the denominator. It's just that the numerators are the numerator of the incremented rational object is the sum of the numerator and denominator. And the implementation, the code, basically implements this this expression. So we use the augmented addition. Numerator is equal to numerator plus denominator, and then the object is returned. Same for decrementing the object. Same formulation will work as well. All right. For the postfix operation, increment operation, things are a little bit different. What happens, we'll basically save the rational object in the temp variable, then increment the rational object, but this function returns the old value, the temp, back because it is postfix operation. You will see this when I demo the code to you. Let's go to the source. First, I will try the augmented operation. Before that, notice that we have already defined 3 rational objects, R1, R2, and R3. Now, R1 plus equal to R2. Basically, this statement, what it does, it adds R2 to R1 and stores it back in R1. Now, adding R1 and R2, this is 2/3 plus 1/3. We should get 1 back. So let's look at the content of R1. R1 toString. We'll run the program here. Let's first verify our rational objects. R1 is 2/3, R2 is 1/3, that's correct, R3 is 8/7, and then we have this augmented addition, R1 plus equal R2. Once again, R2 was added to R1 and the result was stored in R1. 2/3 plus 1/3, that will give you 3/3, which is 1, and that's correct. The result is 1. Now, let's look at the, for now, let's in fact comment this augmented addition and take a look at the subscript operator. So let's look at the numerator of R1, that's R1 at 0, and then also let's look at, say, the denominator of R3, so R3 at index 1, let's say, and line. So we would expect R1, 0, that's numerator of R1, 2 should be displayed, and then the denominator of R3, which is 7, should be displayed. So we run this and take a look at the expression. There it is, 2 and 7. That is also correct. Now, let's look at the increment. Increment, we are going to use the increment in an operation. Let's declare this rational object, let's say R4, and that's equal to, let's first use pre-increment. So this becomes plus R1 plus, let's say, R2. Now, this is pre-increment. So R1 is incremented first. So basically, we are running this function right here. That's prefix operation. So the rational object is incremented, and that updated rational value, rational object, is added to R2. And then the result is stored in R4. So we can actually go to R4 and then call the toString function and see what the result will be. So in here, incrementing R1, R1 is basically 2/3, and when we add 1 to it, this becomes 5/3. So 5/3 plus R2, which is 1/3, that gives us 6/3, which is 2. So the result the result of R4.toString should be 2. And we'll run it, and there's 2. R1 was incremented. 2/3 plus 1 is 5/3. plus R2, that's another 1/3. That gives us 6/3, which is 2. That's correct. Now, what if we do postfix operation? That's very different. In this case, we have the other function called, basically, we have postfix operation. This function is called. And again, the compiler knows, and it will call the function in line 150. And what is the operation here? The old value of R1, which is 2/3, is used in this addition. So 2/3 is added to R2, which is 1/3. So the result is 1. So when we print R4, the result will be 1. But after the old value of R1 is added to R2, R1 is incremented. So R1, when we look at R1, R1 is also incremented, but after the expression is evaluated. So we'll look at that. So here it is. The value of R4 in our expression is going to be, line 18 is going to be 1. That's correct. That's 2/3 plus 1/3. But after this expression is evaluated, R1 is incremented, and incrementing 2/3, adding 1 to it will give us 5/3, which is correct.